Welcome, guys. So we keep solving our physics GRE65. Okay, so a uniform rod of L and the mass M. Basically, you can read the question by yourself, and then you rotate horizontal axis through its basis and accelerations. Okay, so remember that if the rotation axis is here, then the inertia is 1/12 ml squared. If this is L. So by the parallel theorem in here, the I is 1/12 ml plus half ml squared. So this is 1/3 ml. Okay, so the important formula what we need to use is the torque is equal to inertia times the angle acceleration. So this is mg and this is theta. So the torque is mgl divided by 2 sine theta equals to 1/3 ml squared alpha. We can solve the angular accelerations. Basically, the answer is d 3g divided by 2l and times sine alpha. Yeah, so that's it. Okay, so 66. You give 2k, and basically you have two series spring, and ask about frequency. Basically, you need to remember is 2 pi is equal to m over k prime. K prime means the effective of the spring. Since it's series, so the effective spring is k over 2. Okay, so you need to remember this. The effective spring effective k is 1/k1 plus 1/k2, and you do the 1 over this. So from this formula, we know that the effective k prime is k over 2. So plug it into this formula, and then we have this n2. Okay. But remember what is asked about is the frequency. So we need to use 1 over the period. 1 over the period. He asked about angular frequency. Okay, so let me show. So frequency is 1 over t, angular frequency is 2 pi 1 over t. So it's 2 pi 2m over k. So the answer is C. The answer is C. Nice. Okay, 67. Very easy. The Hamiltonian is the kinetic energy plus the potential. So the answer is E. The answer is E. Okay, 68. Basically, all you need to know is the Gauss law, and there should be no charge. There should be no charge for there should be no charge. No electric field. So this electric field in the conducting sphere is 0. So basically, when you do a small surface, this tells you that since this E should be 0, so it should induce a 4Q, and this should be 0, so it should induce 2Q. There's no this should be 0, so there's no induce. So the answer is 4Q, 2Q, and 0. 4Q, 2Q, and 0. So the answer is A is 2Q plus 2. So this is minus 2Q, and so it's minus 2Q, 4Q, and 0. So the answer is A. Okay, 68. The magnetic field is directly perpendicular to the plane of a circular coil of area. So you have area, and then you have terms, and they ask about the electric motive. Okay, so basically electromotive is the change of the average is the change of flux divided by time. So the flux is basically B times N times the area. So epsilon is basically NA times delta B divided by delta T. So we have 250 terms times 0.2 times the change of magnetic field 0.05 divided by 0.25. Okay, so this is what? So this is over 5, and this is 50. So the answer is 50 times 0.2. So the answer is 10. Right, 50 times 0.2. So the answer is 10. The answer is D. The answer is D. Okay, so 70, you can read the equation. You can read the problem. But the problem is that in the real test, you don't have time to solve the Schrödinger equation. So basically, you need to remember some refresh your memory that the important things when K1 equals to K2, then there should be no reflections. So if you use this way, that you know the answer should be D. So 76 is the multiple choice. So key idea is that if K1 equals to K2, then there should be no relation. There should be no reflection. So the answer is D. The answer is D. Okay, 71 x about poly x times poly y. This should you should write down the answer immediately. But if you forget, you can start compute this one, and you can say this is the product sigma. You can compute, right? So basically, you can compute. You can see this because the anti-commutator for sigma poly matrix is 0. So the answer is E. You need to compute this. And the 72 is famous that the binding energy of the nucleon is greatest. This is famous. The answer is the C. So this is important. That the answer is C. Okay, so 73, the muon. Basically, muon you see is basically has a is one of a lepton. So which one is the lepton? The answer is electron. Also muon is a elementary particle. So from standard model point of view, the electron is also a standard particle, and also electron and muon are fermion. So both they are negative charge, both they are fermion, both they are elementary particle. So the answer is electron. The answer is electron. Okay, so 74. I don't have much to say about this problem. Basically, you need to remember the answer that the lepton is basically another. Lepton and quark are both fundamental particles. So lepton contains no quark. So the only answer should be A or B. And baryons contain 3 quarks or 3 quarks and 0 anti-quarks. This is what you need to remember. So the answer is A. Okay, so 75 is the last question in this video. So basically, electron deflect in the scattering, and ask about kinetic energy. Okay, so you know that the Bragg condition tell you that this one. And basically, once you know the lambda, then you can somehow calculate the momentum by the de Broglie wavelength, and this can give you the kinetic energy by p squared over 2m. By the way, this m is different from this m. This m is integer, so you can compute it. So I can view this lambda as basically 2d, or the scale of d. So I can calculate square of d squared 2m d squared, and basically this is the scale. And once you compute, you can get the answer, which is close to 10 eV. This is the computational detail, but you can verify by yourself. And in a test, then you should only compute the tens powers, and without knowing the actual constant. So the answer is C. The answer is C. That's it, and be sure to subscribe to my channel. Thank you. I will see you guys in the next video.